Hello and welcome to Textbook Engineering Problem. We're working out of Elementary Principles of Chemical Processes, 3rd edition. We're doing problem 2.20220. It's a computer problem, so most of it will focus on just using an Excel spreadsheet. Your company manufactures plastic wrap for food storage. The tear resistance of the wrap, denoted by X, capital X, must be controlled so that the wrap can be torn off the roll without too much effort, but it does not tear too easily when in use. In a series of test runs, 15 rolls of wrap are made under carefully controlled conditions, and the tear resistance of each roll is measured. The results are used as the basis of a quality assurance specification. If X for a subsequently produced roll falls more than 2 standard deviations away from the test period average, the product is declared out of specification and the production is suspended for routine maintenance. The test series data are as follows, and then it gives us the test series data. Part A, write a spreadsheet to take as input the test series data and calculate the sample mean and sample standard deviation, preferably using built-in functions for the calculations. Okay, Excel definitely has those built-in functions, so I'll just make those over here. Say the sample mean and standard deviation. In Excel, the mean is called the average, and standard deviation is this function. That's the standard deviation of the sample. Okay. So that's it for part A. Part B. The following tear resistance values are obtained for rolls produced in 14 consecutive production runs subsequent to the test series. Okay, so we'll now add those. These are our production. Okay. And how many are there? There's 14, so it's slightly less than what we've got over here. So I'll just make a new column over here and say these are our production rolls. That's our production run. On a spreadsheet, preferably using the spreadsheet plotting capability, plot a control chart for X versus run number, showing horizontal lines for the values corresponding to the average and the 2 standard deviations plus and minus from the test period. And show the points corresponding to the 14 production runs. Okay, which measurements led to suspension of production? Okay, so let's make a chart. This is our mean. It has an X value and a Y value. Maybe I'll and say X here equals this, and then I'll say our SX, I'll say our 2SX minus equals 2 times this, our average minus 2 times the standard deviation, and 2SX plus is equal to our average plus 2 times our standard deviation. Okay. Back to our chart. We'll say our mean is this. We'll say our lower standard deviation value is this. And then we'll say our upper standard deviation value is this. Go. All right, now let's change these into lines. So we want there to be a solid line, and we don't want our line to have markers. And let's make the line a black line. So no markers, solid line, and we want it to be black. Or maybe we can make it red. Let's make it red so that we know that if we go beyond the red, it's bad. If you go past red, it's bad. All right, but our mean, we can have that be a solid black line. Okay. Oh, but we don't want data points on that line, so no markers. Okay. So that's our window of operation. Okay, so now we need to put in our production data. Okay, so we've got 14 roles here. Oops. 14 roles. And this was our production data. Okay. Okay, but we don't want this to be a line. We want this to be we don't want it to be a line. We want it to be markers. We can make the markers yellow. Yellow's kind of hard to see. Let's make the markers a different color. Let's make them, I think the default is like this blue color, so let's make them blue. So that's the fill is blue and the border is blue. Solid. Awesome. Okay, so that's our production. We can add the legend, we can add axis, titles. Okay, so this is our X tear value, and then this is our production number. Okay. Cool. So then it says, which measurements led to suspension of production? Well, the very first one that was out of spec was number, let's hover over that. That is number 9. So number 9 was the first one that was out of order because it was 37 and our band only goes up to 36. Okay. But then all the rest of these were also high and out of spec. Okay, so let's go to letter C. Following the last of the production runs, the chief plant engineer returns from vacation, examines the plant logs, and says that routine maintenance was clearly not sufficient and a process shutdown and full system overhaul should have been ordered at one point during the 2 weeks he was away. When would it have been reasonable to take this step and why? Well, if we read in the process description, their quality assurance program says that if X for a production roll falls more than 2 standard deviations away from the test period average, the process is declared out of specification and production is suspended for routine maintenance. So they should have done routine maintenance after the very first point, so point 9. Right after they had a run like that, they should have overhauled the system right then, and then it would have saved batches 11 13, and 14, potentially. That is the first indication of drift in this problem. All right, that's it for problem number 2.20. Thanks for joining me. Let me know if you guys have any comments or questions, concerns about this problem, and I will address them as well as I can in the comment section or in the video description. Thanks for your help. Bye.